In today's video, we'll be treating the topic measurements. And under this topic, we have other subtopics which include fundamental quantity or base quantity, and we'll also be treating derived quantities. Now, before I proceed, if you already know the introduction to this topic, please just do well to fast forward down to the later part of the video where I dropped some questions there to be solved. Now, the first one we have here is fundamental quantities. And somebody might ask, okay, what is fundamental quantities? Now, we have to understand that these quantities are independent of other quantities. That means that they can actually stand on their own. Now, in general notes in physics, we actually are supposed to have 7 of those fundamental quantities. But in today's topic, we'll be treating only 3, which are length, mass, and time. And under the fundamental units, we have meter, we have kilogram, and we have second. Then under the fundamental symbol, we have m, which represents meter, we have kilogram, we have kg, which represents kilogram, and we have s, which represents second. Then number 2, we have derived quantities. These are dependent on other quantities, meaning that they cannot on their own stand alone. They have to use other fundamental quantities or even 2 or more of them to actually form a derived quantities. Examples of that now, we have things like area which is composed of 2 lengths. We have density, which is composed of mass and volume, and that volume is also under length because volume is measured in meter. Now, another thing again is dimension. Now, dimension actually includes length, mass, and time. But instead of us to write it in meters, kilogram, or second, we would write it as length, mass, and time. That is exactly what dimension quantities looks like. Now, we have a few examples here to solve, and under question 1, we have dimension of velocity. Now, we all know that velocity and speed are almost the same except for a few differences, but that's not what we're here for. We want to get the dimension of velocity. And like I said, dimension only does with length, mass, and time, represented in L, M, and T. So now, first of all, you think about it. What is the formula for getting velocity? And we have length and time, which is dimension of length divided by dimension of time, which is L divided by T. And once you take this T up, it becomes LT raised to the power of -1. Now, for number 2, we have dimension of acceleration. Dimension of acceleration. This formula is dimension of velocity divided by dimensioning of time, which is LT raised to the power of -1 from up here divided by T. Then if you take this T upward, it becomes LT raised to the power of -2. And the last one is dimensioning of force. For dimensioning of force, we have mass times acceleration due to gravity, but we're going to use the symbol A instead. This A is acceleration. Now, for m, we leave it as m, which is mass. From what I told you, we leave it as m. And for acceleration, which is gotten from here, we leave it as LT raised to the power of -2. And then our answer is MLT raised to the power of -2. So that will be all for this particular topic. I'm going to drop a question now, and you're going to give me the answers in the comments below. And the first 5 to get it, just drop a red heart for me in the comment section, and I'll see your answers. And I'll see you guys in my next video. I hope you enjoyed this video. Bye.